Hello, everyone. I'm Davit Abgaryan. I work as Senior Data Scientist at Disco, and I am going to present recommender systems in market research. Shortly about Disco, the company was founded in US in 2015. It attracted more than $100 million of investment. More than 3 million surveys are completed monthly on our platform, and we are collecting more than 1 billion digital touch points monthly too. And the platform on which we are completing those surveys is called SurveyJanky. It is a place where users or members register, they complete surveys, they earn rewards, and then afterwards these rewards are converted into money and they are paid. And we have the second side where the companies that want information or want to do market research, they provide the surveys. And now talking about the problem that we are trying to solve. So we have opinion sharing platform, which is SurveyJanky. This is the main revenue generating engine of the company. So it's important to optimize that as much as possible. Growth marketing dollars are spent on user acquisition, and naturally the churn rate of the users in the industry is very high. So it's very important to create the best experience for the users to have a lower churn rate. So our problem here is to match users with surveys because not all users can complete all surveys. And as I have mentioned, most of our surveys are coming from third-party providers. And the complicating factor of that is that whenever we show the surveys on our platform, the users click on the survey, but to complete the survey, they are redirected to the website of the provider where they complete the survey. And it means that we do not see the questions in the survey, and we do not see what answers this user is giving. So only whenever they go and complete the survey there, we get a response. This user completed this survey. This user is disqualified or went quota full, and some other statuses. There are dozens of them. That's not important. And in our case, we have a lot of terminations and quota fulls in the industry. And I will say what means termination. Let's say you entered we are doing rule-based matching. Let's say there is a survey project for which we need to have 1,000 completions. They tell that we want women aged 18-24, 100 completions, men 100, then the other age groups and gender groups. And based on that, we are matching our users and surveys, so rule-based one, but it's very high level, like gender, age, and maybe geographical region, but not specific questions. And when they enter the survey, maybe they will ask, let's say, did you watch Queen's Gambit? If you say no, maybe they will say you are disqualified because we are interested in people that watch this movie. Or do you have this disease? Because this is a drug company and they want to do some exploration. That's why they're asking these questions and then disqualify you, and you need to try another survey because you didn't match to this survey. And we cannot, as I have mentioned, as we do not see the questions and answers, we cannot do that beforehand. And the other problem is this quota full. As I have mentioned, for each, let's say we want users aged 18-24 women, and let's say we reach 99 completion and 1 completion is remaining. We send this survey to many people. As you know, it is real time. Maybe 10 people started completing this survey. One of them will be quick and will complete successfully. The others that, even though they completed the survey successfully, will tell that already quota is full. You are not going to get paid nothing. Maybe you spent 15 minutes or 20 minutes. So you can imagine how annoying is that. And we try to lower that rate. And also I want to mention that it's not only us completing that survey. So at the same time, we are competing with other companies like Disco who have users that are completing surveys. So there is competition between the companies to complete that provider surveys. So we have a problem. We do not see questions. We do not see answers. And we cannot solve that. No one is going to share that information with us. But there is a workaround. and quite interesting one. So we can do personalized survey matching. How does that work? The logic is this. Let's say we have Anna. Anna completed survey 1, survey 2, and survey 3. And we have John that completed survey 1. So it means, in this case, it's one survey, but in reality, it can be 100 common surveys. It means that Anna and John, we do not know how, but they are similar. And it means that if there is a survey that Anna completed successfully, in this case, survey 2 and survey 3, we can recommend to John. So as they are completing, completing successfully similar surveys. For some reason, we do not know underlying factors that they are similar, but we know that the probability that John will complete these surveys is high. And let's say we have Nare that completed only survey 4. We cannot give any recommendation because there are no similarities. And we have survey 1, survey 2, and Armen completed survey 1, survey 2. We will take survey 3 and recommend to Armen. So this is very simple logic. We do not do it manually or rule-based one. The data science approach of solving this problem is recommender system. And we will talk about what recommender system, what type of recommender systems there are. And there are personalized and non-personalized one. For example, popularity-based model is non-personalized one. It's very easy. Let's say we have Amazon and Amazon wants to make recommendations. They can just get the most popular item that is being sold a lot to everyone. Or music recommender system. This song is very popular. If majority of the people are listening, you can recommend to other people as well because most of them like it. But you know that it is not a perfect solution. The better solution is personalized one. In case of personalized recommender systems, we have content-based, collaborative filtering. These are two approaches, and the hybrid is the combination of the two. So content-based approach is when, as I said, we have John and Anna. When they register on our website, they give us their profile information. Actually, they're answering 16 mandatory questions, including age, gender, are you marital status, education. And based on that, you can, based just cosine similarity, calculate the similarity between the users and give recommendations. My colleague is working on this, and this is performance is not that good as if compared to collaborative filtering, but it has one advantage. First, let me present collaborative filtering. In case of collaborative filtering, you are calculating the similarity based on of the users, that's based on their historical activities. So in my case, I presented how the surveys that they completed, what was successful and what was unsuccessful. So no profile comparison, no feature comparison, only historical activities. In case of e-commerce website, it can be the user clicked or liked or the song. It can be liked the song or didn't like the song. So in case of collaborative filtering, we use only historical data. But there is a very common problem. It's called start problem. It's when, let's say we have a new user. We do not have any historical data on this user, so we cannot make recommendations. Or if we have one or two completion or attempt, we call it attempt, this data is not enough to give good probability, generate good probability on the recommend that survey. So that is called cold start problem. And in that case, content-based approach works better because you say that as these two users' profile are similar, the likelihood that these users will complete similar survey is very high. And also, I want to mention another important thing. It's not only the users are similar and they will, if they completed successfully 50 surveys, they have 50 surveys in common successfully completed, then we can recommend good surveys, like the survey that one completed and the other one didn't complete it. We can recommend that to that person, but we can also unrecommend surveys. So if I went quota full on this survey, we will not give the same survey to the person that is similar to you. So if we see that you have a lot of common quota fulls, it means that you are similar in quota fulls as well. So it is negative things, but you are similar. And when we see that the probability to go quota full is high, we will just not recommend that survey because you may get a quota full. So in case of collaborative filtering, so this is the approach. And implementation of collaborative filtering can be with memory-based models and can be memory-based and model-based. In case of memory-based, it's, for example, k-nearest neighbor. In this case, you do this similarity calculation in real time. But the problem there is that if your users, the number of users and the number of surveys grow, it's very hard to do that calculations. Like you will have latency issue. In case of model-based approach, you do the calculations like you train a model beforehand, and then whenever the users come, you make a prediction. But you need to make sure that your model has the user ID and survey ID, so the users and surveys should be in the model. So it means that if you want your model to be comparable to this memory-based approach, you need to retrain your model very frequently. For example, in our case, our model is retrained every 2 minutes. In order to have the new users and new activities of existing users, so or even new surveys. So it's very important to update the model as fast as possible. So in case of model-based approach, the popular one is matrix factorization, and there is implementation like of matrix factorization, which is called factorization machines, and it's more advanced than other matrix factorization approaches like SVD, singular value decomposition, for example, or there is SVD++. So factorization machines, we will talk about that. Factorization, the seminal paper of factorization machine was published in 2010 by Stefan Rendel. And the advantage of this model is that it is, can be trained in linear time. It is linear time estimation. Compared to matrix factorization, in which case you have NM. Let's say N is your users and M is your surveys. So you always have NM parameters to learn, which is not, compared to this one, is not linear. So, and this one is also handles sparse data. For example, in our case, the data is sparse because not all users are trying all the surveys or and here is the formula of that, like the estimation, the loss, like the function that we are optimizing, the parameters that we are learning. So the number of parameters here is P, which is this part, the linear part. And in here, we have interaction term. So interaction term shows like we are learning parameter between a user, this user completing this survey. For all of that, the model is learning parameters. And as you can see in this case, it's not just one coefficient. It is a vector. And in that vector, this parameter k, which you can change when you are training model, you can say, I want a model that has only 2 elements. I want a model that has 6 elements. So if the complexity is higher, then you will increase the number of this k. But this is hyperparameter that you can tune. So, and with this model, not only you can solve like recommender system related tasks, but you can even do regression, like logistic regression, like binary classification and regression tasks. And there is a very good implementation of factorization machines. The library, the package is called Xlearn. Underneath, it is working with C++, so it's very super fast. It's high performance. It's quite easy to use. Actually, the data structure is very specific. It uses SVM. I don't know whether you are familiar. If you are fine with the data processing, like to give the data in a shape that it requires, then it will be very super fast. It has out-of-core learning, so it's not like if the size of your data is very big and you cannot give it at once. You can do it in, by batches, and it also has online learning. You do not need to retrain the model all the time. You just can give them the initial data. So here you can see the comparison on single MacBook Pro with libFM, FFM, and libFM and linear. So the performance, how execution time, how fast is that? And in case of factorization machines, there is also field-aware factorization machines. So field-aware factorization machines means that, for example, I was talking users' age, gender, or for survey we have parameters called like payout, duration of the survey, and the conversion of the survey. So these parameters you also can give as an input to your model. At the moment that we do, we do not use that, but you can give other parameters to the model. And yeah, before passing to the next to the next slide, I want to mention that this is used for CTR, click-through rate prediction, and this model was used to win multiple Kaggle competitions. Actually, this is 2010 model. Now there are more advanced models. Even you can have this BERT model or transformer models and other models to solve that problem. But in our case, from the business point of view, we do not want to have the most advanced one. We want to have something that works in production, and then later you can optimize that. So it's not a Kaggle competition. In the business, they want predictability and stability. And here with these things, at least so far, we have seen that. So how the model training happens, it may sound surprising, but we just give this user attempted this survey, was it successful or no? This is the only data that we give as an input to this model to be trained. At the end, whenever the new survey comes, or you want to see, not new survey, but if this user didn't complete this given survey, we just give as an input user ID, survey ID, and it will give you a probability. It can give 0, 1, but it can give, like in case of binary classification. Actually, at the end, this is binary classification task. So this factorization machine, at the end, you are training model like you would train a logistic regression model. Actually, binary classification, let's put it that way. So here we are taking last 1 month's data, and then we are training the model, and then we take next 1 day's data, and we are assuming like in next 1 day we have this user attempted this survey, and so the model does not know about this data, and we are calculating the probability whether this, what is the probability that this user will complete this survey, and we have the actual value. And based on that, we are doing sorting of survey for 1 user. Let's say 1 user can have 100, let's say 100 survey, or in this case, we do 12 recommendations. And we are comparing precision at K, how many of the predictions were correct. And we were increasing the conversion rate. The conversion rate shows out of 100 attempts, how many will be successful. We have seen that we increased the conversion rate a lot. So talking about the engineering part, like our infrastructure is, we are on AWS cloud. So here you can see we have Amazon Redshift. This is our database. The historical data is there. So through the model, the code is running on Amazon SageMaker. It's Jupyter Notebook, querying this data and training it. So we use Amazon CloudWatch for scheduling the model. Actually, this model now is not scheduled because we do not even turn the instance. So as I have mentioned, it is retraining every 2 minutes. So when 1 training happens, the next one after that starts the next one. So this instance is not turned off, but we have some models for which we use Amazon CloudWatch. So we say the model, you need to start this instance every day at 1 p.m. And that is done by CloudWatch. And we use Lambda function to start the instance. So we use this Amazon API gateway. So if something happens with this error, here we have try except. If something happens, we want to restart the model. So it closes itself, but before that, it sends a request to Amazon API gateway, which comes and restarts this Lambda, which comes and turns on this instance again. So that's not that important. And model saved is on S3. S3 is a storage. Some of you are familiar. It's like the disk of your computer. So this is the training process. And from the endpoint, we have the fast API endpoint, and it reads the model and data from here. Actually, I use Slack for reporting. For example, if something happens with the endpoint, I will get reports on my Slack. That's not the best way to do this. For example, there is Opsgenie and other approaches, but it's very convenient, at least for me. So the user, when user enters SurveyJanky, it makes, there are some other things happening, but our endpoint gets the surveys that are matched for this user. Then we take these surveys and we just rank them based on the probability. So here, this part actually changed. We here have EKS cluster on AWS, and we have CI/CD pipeline. So our code is on GitLab. When we push changes to the GitLab, that will trigger, build, and deploy. And this EKS cluster will be updated in real time. So we do not turn off the endpoint or switch off. It will, there are 32 instances. So it updates each instance, the code for each instance sequentially. So talking about the performance, one request is handled. The prediction happens in less than 70 milliseconds. And for example, during last week, we handled 140 million requests and without major problems. So this part is old. So this is the fast API code. I think nothing is seen here, but this is the structure. They are making post request to us. We are getting the surveys, processing, and giving a response. And we have also background tasks. For example, background task goes and brings, let's say, real-time conversion and duration of that survey on our system. If someone will be interested, I am happy to share what we have there. And also, I want to mention, as I have mentioned, stability is important. For example, one of the issues that we encountered is memory leakage. Sometimes in your code, for example, we were using HyperGBM model, not for this one, but we were using HyperGBM model for predictions. And it can happen that you know that the Python's memory management is not the best. It handles automatically, but it's not the best. So maybe after handling several requests, 100 or 200, by the time your memory will be filled in and your endpoint will crash. So that happened in case of Xlearn as well. For example, instead of using its Python API, we switched to its shell version. Then this problem solved itself. Instead of Python, we used shell version. So I think there are some other problems that we encountered, but that's not like if I can answer the questions related to that. So talking about impact, so we are increasing the conversion. It means that we are increasing both user satisfaction and the revenue of the company. And actually, during last month, as I have mentioned, we are competing with other companies as well. There is a big marketplace. It's called Lucid. Actually, it is the biggest company in market research. And on their platform, we became #1 by earnings per click after implementing our model that we have. And it means that our users now are making 20 to 30% less clicks, but are completing more surveys and earning more revenue. So we are they do not need to try many times to get the survey on which they will convert. I think that's it. Thank you.
Okay, time for questions.
Thank you for your presentation. It was very great. I have 3 short questions. First of them, did you try LS alternating least squares for matrix factorization? How it compared to your method? Another question, did you try it? You said you use as offline metric for your model as precision at K. Did you try it in DCG or something similar? And how do you evaluate your model performance in production? Do you have some A/B testing decision? Thank you.
Thank you, but the first question was, so let me come from the end and you will repeat the question.
Okay.
So sorry. So about talking about testing, so whenever I say this precision K metric, in reality, you train your model. Actually, the score for evaluating the model, this factorization machine model, I am using ROC-AUC score. So because our data imbalanced, so with ROC-AUC score, we are choosing the best model. And as I have mentioned, we are using this 1 day's data to do the evaluation, but that is not correct as well, because in reality, we need to, as I have mentioned, you need to retrain the model every 2 minutes because you need to take into account all the new attempts of that user and survey. So that evaluation, even that one, okay, we see everything is good, but in reality, there are many factors that can affect the performance. So the best way to see your model's performance in real time. In our case, all our users are segmented into 10 groups. We started running like 90% is the control and 10% is our model. When we see that it is performing well, it's not only one metric, but okay, I cannot show it now, but we have 10 metrics. So we have the number of completers, earnings per minute, earnings per click, the revenue as a like the absolute number per user. We have conversion rate, quota full rate. So we are considering many, many factors, comparing test with control, and we make sure that we run it quite long, because in short term you will not see. So at the moment, whatever we like, 90% is running on our model, and even I would say 100%. The other 10% is the new model that we are testing. So we started with just 10%. Now it's running on 90%, and it is making the impact that everyone wants.
Okay, thank you. And another question is ALS, alternating least squares.
Actually, I heard about that model. I do not remember whether we tried or not, but if we are talking about the models that we tried, one is, for example, one popular one is SVD++, singular value decomposition. If I am not mistaken, it was showing similar results. But as I have mentioned, this model is, first of all, matrix factorization is like the complexity is in linear time. And the biggest advantage, I would say, is this xlearn package. Because in the other cases, you need to implement it from scratch. But it is done in C++ underneath. It's very efficient. Like it was done by Chinese team. So they did very good job. So that's why we are using that. So the speed is very important for us. We need to make sure that, like with the old one, all the model that they have, the latency was like around 5 milliseconds, the computation, because it was like simple formula. With this approach, initially our request, like we were predicting in one request, prediction was happening in 1 and 5 seconds. Then we see like we wanted to do pre-computing, like calculate all the probabilities, but I didn't beforehand. And then when user comes, we give it to them. But the problem with that is we have, let's say, 500,000 users and a lot of surveys. I remember we needed to calculate 5 billion pairs every 30 seconds. The calculation we were doing with parallel processing, but the problem was to separate and give to that user. Mm-hmm. So because it didn't work, we I changed my whole code of request, like handling the request, and from 5 seconds, it became 70 milliseconds.
Mm-hmm. Okay, thank you.
You're welcome.
Thank you for presentation. I have a question. Like for new users, like know any information, how do you solve inference problem for new users?
Yeah, actually, whatever I present it's just the tip of iceberg. So whenever we get this probability, this user completing this survey, it is personalized conversion rate, this user completing this survey. We also have survey conversion rate. So whenever a provider is giving as a survey, it says that I want this many surveys to be completed, but also it says 3 main parameters. One is payout, how much they are going to pay us for one completion. One provider, for one project, they may pay, like on average, if I am not mistaken, it's $1.8 for one completion. The second parameter is duration. Let's say they say the survey on average will take 15 minutes. And the other thing is conversion rate. So they will tell that the conversion of this survey is 50. So it means that out of 100 attempts, on average, they will say that 50 completions will be successful. So whenever we take these parameters, and whenever the new user is new, we already have these parameters, and based on all the projects that we have on our platform, we know this survey's performance. For example, we know that this survey is high conversion survey. Then we are going to give this recommendation to that user. So, okay, we are not sure that this user will complete this survey, but surveys differ by their conversion rate. Let's say if they want someone that has PhD, its conversion rate is different than the person that they want, let's say, to know how they are going to vote in upcoming elections. So we have the levers there. And for new users, we are concentrating more on conversion. And for existing users that are experienced, we convert on payout. So continuing that, we have an approach called multicriteria optimization. So this payout, duration, conversion, and also personalized conversion, which is we get by this factorization machine, are combined together by coefficients. So based on historical data, we learn coefficients for these parameters to maximize the revenue. If we want, you can maximize other parameters as well. We say what coefficients we need to have, like how to combine these numbers together to get a score, by sorting which we will maximize our revenue. So why this? You need to equilibrium. So you can recommend the highest payout surveys to the user, but as the conversion rate of these high payout surveys is very high, you are not going to get enough completions, and your overall revenue will be less. But you can recommend them a lot of high conversion surveys, but their payment will be low, and at the end, you will not, again, maximize your revenue. It's like producing expensive cars like Lamborghini and selling 100 of them, and producing mass production cars where you sell each by, let's say, $10,000. And you should not necessarily think that expensive cars are making more. For example, Lamborghini, if I'm not mistaken, at the end was bought by Volkswagen or mass car producer. I do not remember. So our goal with this multi-criteria optimization is to maximize the revenue, balancing the payout, conversion, and duration. And yeah.
Oh, okay, thank you. And I have another question, like related to this information you said. Like, do you use this information to learn content-based system? As I understand, you are using collaborative filtering, yes, methods like factorization machines, but you have another attribute data, so you can use also like content-based system. Do you do that?
Yeah, as I have mentioned, my colleague is working on that. We have XGBoost-based model. It's just, you can say, binary classification, where we give as an input user profile data and survey data, this payout, duration, conversion. And based on that, the model predicts whether this user is going to complete this survey. So how it works, historically, it learns based on historical data that the user with this type of profile completed this survey and didn't complete the other one. Based on, and also you have these survey parameters. Based on that, it's generating probability between 0 and 100, and we are doing ranking.
Okay, thank you.
Thank you, Tom.
Any other question?
Thank you very much for the great presentation. And just a small question about the new users. So I guess when they are registered into your platform, they give you some demographic information, right? And do you use them to do like basic recommendation? Do you have any initial models which use just demographic information without historical data, and to give them some recommendation based on that?
So as I have mentioned before, even when there were no data science models, when, let's say you are a user, you enter the website, you are a new user, we need to go and match surveys, like defined, let's say we have inventory of 5,000 surveys, we need how many of them match you. There is a rule-based approach. For example, you are age 20, your age is 23, you are man, and you are located in some US state. When they give us that data, we do rule-based matching, so this is 100%. But afterwards, no matching is happening. So as I have mentioned, we have this, my colleague is working on this content-based one, and this is, it is getting all this demographic data. Whether you are married or know what car you have, whether you have children, educational level, all this stuff are getting as an input to that model, and they are making prediction. But as I have mentioned, like this is not as precise as this historical data-based one, but in the case of new users, that approach is better.
Okay, great. And another small question about the model performance. So you train your model every 2 minutes, and your conversion rate, you said, increasing over time. So can you give us like general change of the performance during the last 1 year or last 2 months? How fast your conversion rate is increasing?
Actually, as I have mentioned, it's important to increase the conversion, but it's not our goal. So our goal is to maximize revenue. So even if we can increase conversion, we are not going, like we care about that, but if we can increase revenue more and keep the conversion as it is, even that is good for us. So in all the model that we have in production, when I said earnings by click, we became 1. In that case, we were increasing the conversion by 20% for all the users. But I want to mention other things. This is something internal, but in our case, we have different integrations. And because of the way that like we are a startup, we grow very fast, we are not able to affect 100% of the users. When I say 100% users, I mean 100% of the users that we can affect. The other part still we cannot affect, but in upcoming months it will be, so it is infrastructure change. So the ones that we impact directly, the conversion increases by 40% even. But you should, 40% in percentage terms. In absolute term, this is internal information. I cannot tell you what is our conversion, but you can assume that it's not high. As I have mentioned in the beginning, the churn rate is very high and the conversion is very high. When I joined first Disco and I tried the product myself, I said, how can happen that people are making money with this? Because you need to attend hundreds of surveys to be able to complete, let's say, 10, 20 surveys successfully. So it's not that easy, and we are trying to improve the user's experience. Yeah, thanks.
Okay, thanks.
No other questions?
Thank you for your presentation. I have just a technical question. So from the point of view statistics, yeah. We aren't getting randomized samples. They are chosen. Is this correct or not from the point of view statistics of randomized trials?
You mean, are we talking about A/B testing?
No, when we are when we need to take a survey, it should be randomized to include whole the population. So when we are choosing from the population different people, so the conversion rate would be higher. Then our sample of people isn't truly randomized. Is this correct from the standpoint of statistical inference?
So, yeah, theory and business are totally different things, and I wouldn't say that whatever we have is statistically correct. I hope it's not surprising. You should, for example, it is not the only problem. It is much smaller problem than, for example, the fraud. Many people can come, register, create 100 profile and tell that, and use this 100 profile to earn points and just redeem. So we have bigger problem, but the purpose here is whenever provider comes and wants to make a decision based on that, they not only think about the accuracy, have something that is representative, let's say the population of United States, everyone wants that, but that is very costly. I think practically impossible. So your goal is to have good enough data based on which you can make decisions. And it's also about the speed. If you can tell me that you will have statistically correct surveys completed in 6 months, my business cannot wait that much time. If you can tell me that you can give me results 5% less accurate, that within 1 day, I will be happy to use that. So, for example, again, when I joined Disco, I thought, how they can do completing surveys online. Who is the person at in front of computer? How can be sure that the quality of data is good? But we have what we have. This is a $17 billion industry, and people want to make decision. Like having some data or some impression how people think compared to having no data is much better. So we just make sure that it's as accurate as possible, but as I have mentioned, that is not the most important factor here. So regarding that, I want to add something that is important too. So if, of course, we have time. So not only we are gathering opinion data, we also gather behavior data. So if someone asks you how many times you are doing making purchases from, let's say, Amazon, you may say 2, may say 3, but this is changing. You may be not remembering. So, and your opinion may change. Your behavior and opinion are in reality different. You will agree with that, yes? So whenever you express your opinion, it's not necessarily mean that you are going to act like that. So when I say we gather these 1 billion digital touch points, we have an extension. You install it on your computer. We pay you for that. We get your consent to gather all your actions on e-commerce websites. And what you search, what actions, did you add something to basket or something like that? No other websites, only e-commerce. And when you do that, we are not only tracking your actions, but also we send you surveys to complete that, and we compare the results. And we have very hot product now. It's called ad measurement. And we have very big clients. For example, one was Oscar ceremony. So let's say they want to make an advertisement, a video or something like that. Okay, we are out of time. So everyone can go, but let me finish that. So talking about Oscar ceremony, so before spending, let's say, $10 million or $50 million on ads, they are paying us less amount of money and to do testing. One group of users are seeing the advertisement and the other group is not seeing. And as we are tracking their actions, we see whether the people that see the ad are affected or no. And based on that, then they decide whether the lift is enough and they should spend this $50 million on the advertisement.